Hey, this is State Representative Seth Grove. I'm outside West York High School. We're going to go in and check out a few classes, checking out the cool things West York is doing. But in general, I'm trying to get a glimpse of what's happening in our local high school, some awesome classes, some awesome educational opportunities that each student will have at each of our different high schools here in the 196th district. So I hope you enjoy these 3 education promotion programs and learn a little bit about the excellence in education that's happening in the 196th district. So here we are at Materials Production. I'm here with one of the teachers, Al Janesek. Did I get that right?
Janesek, yeah.
Janesek? All right. So obviously career and tech education has increased in value over the past decade. We have a lot of individuals retiring, thousands upon thousands of job openings within the career and tech education field. So give us a little history about career and tech here, maybe what courses are offered by West York.
Okay. One of the courses you're seeing right now is our engineering course. We have, we want to reach every student and we want to prepare them. If that means going into the engineering field, we want them to be good engineers. That means talking with machinists, talking to people in the field, having that technical background. On the other end of it, if you don't want to go to college and you want to go into the trades, which is great, we want you to be prepared for that. You open up the hood of a car, you open up a furnace, you're not just turning wrenches, you're using technology. There's the technical side of it. So we're trying to reach both ends here. So
that's great. So this is materials, and you embed your kind of engineers, those who want to become engineers, embed them right in with kind of like the day-to-day process. So they have the communication. When you hit the job field, you have to know how to talk to individuals, how to respond, and have a fundamental understanding of what their jobs are, right?
Right. If you're going into engineering, you need to know what your company's capabilities are, materials, machines. Maybe you design something that your company can't make. So we want them to have that technical language in the background, and on the other side of it, we want the field technicians to be able to communicate with the engineers, and just want the students to know that if you go into a technical field or a technician field, you're not just turning wrenches. It's definitely the times have changed.
Awesome. So when you're dealing with students, particularly parents, and the student has an interest in career and tech, parents are, I know my dad was a tool and die maker. He wanted his boys to wear a shirt and tie because that is what he viewed as success, not doing what he did. But it's not the case today. I mean, you can graduate a 2-year, even graduating high school, great family sustaining pay, no student debt, doing some awesome job opportunities out there. How do you get to those parents to say, this isn't what you experienced growing up? It's a different field today.
You got to educate them. I'm not anti-college. I'm anti-debt.
Yeah.
And I hate to see people go into these fields and then they got this huge debt. And also, I have a lot of friends in the trades. It's great work. And sometimes there's that stigma that working in the trades is lower, and it's not. There's people with 4-year degrees that have to go, and when their car breaks, where are you going? You're going to somebody in the trades. So
it's interesting. We're starting to see data of more 4-year degree earners going back to a trade school to get trained so they actually have a job outside of it. Talking to Thaddeus Stevens, one of their largest cohort of kind of freshmen enrolling are 4-year job seekers. When you talk to these kids about jobs afterwards, do they connect the dots on pay, no debt, and doing something they enjoy?
Well, that's what we try to do.
Yeah.
I mean, part of this course is what's available out there. At this high school, we offer so many different things, but what are your options? Because they think, college or workforce, and there's a lot of things out there that you can do. So really just educating the students, bringing other speakers in, I teach electronics. I have a electronics or electrical apprenticeship guy coming in to talk about the opportunities that they have. So
That's amazing. What other career in tech options are here at West York High School?
We do screen printing, we do graphics communications, which there's 4-year degrees and 2 years degrees. We do electronics and electronics technology. We do manufacturing. We offer materials production, both wood and metal. So, if a student takes a few classes in our area, he or she should have a good idea of what or the general direction of where they want to go to when they leave here.
What do you see as a growing area within career in tech? Computers, kind of your engineering side.
And the country needs engineers. Yeah. We need engineers. We also need technicians. We need HVAC technicians. We need automotive technicians. We need people in the trades. So.
Within your enrollment here, though, at West York, what do you see? What do you see the interest of students gauging?
They like working with their hands.
All the above.
They like working with their hands. They like being creative. They like designing stuff. They like making stuff. So, a little bit of everything.
Good. As a career in tech program, are you partnering with other businesses to get obviously equipment? Huge cost is equipment, right?
Yes.
Are you getting secondary equipment from businesses, building those partnerships?
Yeah, we're using the money where we can get it. For example, this project that we're working on, we got a grant from First Energy, and we're using that grant to fund some of the motors, the batteries for our robotics project. So we have some mentor engineers that come in. So we're working with some companies and sort of just collaborating to just get out there and find some money.
Now this is kind of introductory level. They're making a tray, and you were telling me the goal is to actually battle two robots against each other.
Yes, that is. If you've ever seen, there's a TV show that airs sometimes BattleBots. We're doing a smaller version of that. So they have to design the robot. There's the engineering portion of it where you design it, you have to program it, but then you need to build it. Yeah. We need to bend sheet metal, we need to weld, we need to drill, we need the technical skills. So that's why this is a good project to encompass a lot of those different skills.
It's amazing. And do you need to learn some coding to instruct the robot how to move?
Yep, a little bit of logic. We need basic electrical, Ohm's law, voltage, current, resistance, those types of things, switches, control. So it's a good all-around project.
Awesome. What other cool projects do you do at West York around career and tech? I know there's at one time pumpkin chucking with catapults.
Yes, we do pumpkin chunking, which if this class was in the fall, we'd be doing that to where we could engineer a device to throw a pumpkin and then actually build it. In our other courses, we'll build bridges and we'll destructively test them. Designing, the previous project in this course was designing a land yacht, and we raced it around the track. So, yeah, I mean, you gotta reach out and you gotta shoot big and see what they come up with.
They probably enjoy a lot of those projects as well. I imagine the pumpkin chucking is pretty...
It is pretty good. It's county-wide, and I think we had 16 different schools last year. And it's a big project. I mean, you're throwing a pumpkin, a couple hundred feet, an 8-pound pumpkin. So we did pretty good last year, so we'll continue to give it a try and get them interested.
Awesome. And anything else you want to highlight?
No, I mean, we need people in the trades, but I'm not going down on a 4-year degree, but we need people in the trades and we need hands-on technicians. So,
awesome. Appreciate it. Thank you so much.
Thank you very
Al.
much. I appreciate it.
Keep up the great work here at West York School District.
Thank you. Thank you for coming by.
Do Did you know that Violet Oakley was the first female artist to receive a large commission for artwork done in a United States Capitol building? In 1902, Joseph Houston, designer and architect for the 3rd Harrisburg Capitol building, commissioned Violet Oakley to paint murals for the governor's reception room. He believed that Oakley's contribution would add interest to the building and act as an encouragement of women of the state. Prior to beginning her work for the Capitol, Oakley set out to England to conduct research for her murals. Upon return, she decided to center her artwork on William Penn and the founding of Pennsylvania. Oakley made sure that Penn's ideals of justice and peace could be seen throughout her work. In 1906, she completed 13 murals titled The Founding of the State of Liberty Spiritual and was placed in sequential order around the governor's reception room. These murals were some of the first to be installed in the Capitol. When Edwin Austin Abbey, another artist for the Capitol, died in 1911, Oakley was offered another opportunity to create murals for the unfinished Senate and Supreme Court chambers. Her work on the Senate murals, including International Understanding, was completed by 1919. Oakley then completed the Supreme Court murals, including the Divine Law, by 1927. Oakley is said to be the principal artist for the Capitol, with a total of 43 murals on display. She remains one of the greatest muralists in the United States. Now you know.
Did you know that the state capitol is not only the epicenter of the Commonwealth's governing bodies, but was once home to 390 preserved Civil War flags? During the war, it was customary for each state to furnish their regiments in battle with flags representing their contribution to the Union Army. After the war, Pennsylvania's military department was responsible for collecting the flags, and in 1872, they were reverently housed in the Capitol. Following the completion of construction on the new Capitol building in 1914, the Civil War flags were moved to the Capitol Rotunda. They were kept untouched in custom-made flag cases until 1982, when the Capitol Preservation Committee initiated its Save the Flags project. Throughout the years, dust and long-term vertical display of the flags had begun to devastate the brittle silk fabric and painted designs. The flags were removed by local textile conservators and were repaired and preserved in storage units that protect the relics from light, dust, and excessive handling. Now you know.
Thanks for joining us again. Here we are with Mr. Wolf, physics teacher here at West York, and they have, I think, a very innovative approach between engineering and career in tech, because a lot of times engineers and people who have to make the designs as engineers, sometimes it doesn't work out quite well. So you had a brainstorming idea, early 2000s, came to fruition. This is the first year for that, correct? Give us some background and how it's working.
Well, the idea I had was based on experiences of my students. You know, I'd ask them to make something and they couldn't do it. We also run the Pumpkin Chunkin', the county Pumpkin Chunkin' Championship. But every year my team, I have an AP physics team and I have a tech ed team. And the tech ed team always does better because they know how to build things. And so it just seemed natural that we would have a team comprised of the two. And so that's what we're trying to do in this program now. We've mixed together the AP and honors kids with the tech ed kids so that they can build and design and work as a true team.
That's amazing. And it's real life experience, right? You were telling me about was it your father or father-in-law?
Right.
Who?
Yeah, my father-in-law, you know, he's a machinist and he always had to deal with new engineers coming out of college. And he always used to say that they always had the book knowledge, but when it came to putting something together and making it actually work, they had no idea. So he was 100% behind this.
Amazing. So we were down at the material technology and they were bending some metal. Eventually they're going to be making robots. So what you're doing here today is a precursor to that as well. You're looking at the motors and the engines of the robots. So they're just doing their preliminary work understanding how that operates, right?
Correct. And most of the kids have had electronics 1 and 2 and some AP physics 2, some electricity. some have not. So I've taken that opportunity to pull the kids that haven't had any electricity experience and teach them a separate lesson. And the ability for me to work with the other teachers, it looks like we're completely separate, but in a few weeks we'll probably all be together all the time, and then we can kind of bounce around and help. Right now these kids are learning about Arduino and microcontrollers. How do they actually make the robot do what they want it to do? That's the goal of up here.
So you take that information, you go to the material technology class, we're going to eventually build the robots and coordinate the functions of this class with actually building at the materials.
Correct. So right now this class is with me every other day. And so tomorrow they'll be downstairs working on the motors and the toolboxes and the metal. They have to use composite structures, so they're hopefully going to learn how to use fiberglass and materials like that, the newer composite things. But it absolutely is one class. It's not two separate things. And I think for us that's what's so innovating. I've talked to a lot of my peers around the county, and they've had engineering classes for years, but it's always one or the other. And so us mixing the expertise in physics with the expertise in materials tech, I think is fairly creative and innovative. I'm not sure of anybody else that's doing that.
Yeah, it's pretty groundbreaking for breaking down those
We'd like to
barriers
think
in
so.
communication. So it's excellent, great work here. Outside of engineering you've had for a while, this is a new kind of design of a class. What other career and tech kind of education hubs or other partnerships are you looking at here at West York?
We're always looking to increase some flexibility in our schedules. Currently, we're one of the few schools in the state that requires all students to take physics, chemistry, and biology. So they have to take all three, and they get to choose what level. So we're talking about doing some things where instead of straight up physics or chemistry, looking at classes like how stuff works. So the kids can really understand how the phone that's in their hand that they can't get away from works. And things like that in their daily life.
Try to drive it down to applied education. So you get the theory and how it works, so you don't get that age-old question of why am I learning this, right?
And so often you hear the term applied physics. Well, if you actually look at applied physics in college, it's one of the hardest curriculums because physics itself theoretically is fairly easy to learn. It's just what do you do with this knowledge? Something new and inventive, and that's what makes it difficult. So we're trying to do that here.
Awesome. So as these kids progress, they're starting with kind of basic facts. What size motor and what's the end project that they're going to be working on?
Well, it's completely open-ended to them, but we did receive that grant from First Energy for $1,000 that allowed us to buy different materials. And so each group has been provided with an 18-volt, actually two 18-volt drills that they've torn apart. I think you saw that downstairs. And so they can use those however they see fit. If they want to use them to drive the vehicle, they can. If they want to use them for some type of weapon, they can do that. But we're also providing them with the Arduino microcontroller, and they can decide what sensors that they want to use. So it could be an impact sensor or a proximity sensor that they then have to program and say, all right, if I sense something within this distance, activate another motor, make something happen.
Wow, so you're also going into code
Correct.
to inform that robot how to operate.
Correct.
So they get code within this class too. How long does that take to teach, or is it?
Well, we started it last week, and they're doing it slowly. It's going to be fairly basic. We've had a number of kids who've had programming classes, so that helps. But the code that they're using for the Arduino is a little bit different, so they have to just learn that language. Really, we decided to do that because no matter what branch of engineering or skilled trade, kids are always going to have to be on the computer and trying to debug something or troubleshoot something. And so regardless if they're AP or tech ed, they all need to learn some basic stuff.
So when we talk about physics, maybe science and STEM education in general, huge skills gap. Like we just, tons of retirees coming up, and we're not able to fill those jobs coming up. So how critical is it to focus on STEM education in high school?
I think it's extremely critical. Obviously, it's something I'm passionate about, and I love doing. They're difficult skills, but there's certainly nothing that can't be done. And so I think if we focus on making it understandable, make it applied to the kids so they understand why it's important, the kind of jobs that they can get with it. And I focus in physics, but really physics kind of governs all of the sciences as well. So if they're taking chemistry, if they're taking biology, and in all of our classes we try to kind of integrate them together. When I teach physics, I'm often talking about biology, biomechanics, things like that. Or in chemistry, I know they talk about biochemistry and how that all fits together. So for the kids to learn how important it is to them personally, but then also the jobs that are out there. And those jobs aren't straight physics. Like, I mean, you could get a degree in physics and go out and get a number of jobs, none of which will be entitled physicist. And so that's really what I want them to see here, that whether it's an engineer or a scientist or a skilled trade, a plumber, HVAC, electrician, they all need to know some basic science and basic physics to be successful. So that's kind of our goal here with this program.
And this is a joint venture, right? You don't have all physics students at each of these groups. It's kind of a commingled.
Well, one of the prerequisites of the class is they all have had to pass physics, which for us is a junior year class for college prep and honors, but it's a freshman class for the applied group. So some of them might have had applied physics in 9th grade 3 or 4 years ago, and some of them might have finished physics last semester. And so the ability to see the AP and honors kids and their depth of physics knowledge and problem solving is a whole lot different than the applied kids, but they all have to work together. One of the things that we've done in this curriculum is not just science, but we've done units on teamwork, team building. How do they work together as a team? How do they use each other's strengths? We've talked about the engineering process. So while we teach physics, I'm trying to do a whole lot more than just the science curriculum.
Try to ingrain what actual employers are looking for, because everything is team-oriented, teamwork, how to work in groups, even though you may have some personal differences, how you move past that to complete a project on time, under budget, all those things.
And I have a couple of students who really decided after scheduling this class last year that they don't want to go into engineering or a technical trade. I have a couple kids who want to go in the financial field. And so they still have to learn how to work together, utilize each other's strengths, and more importantly, they might end up getting a business job with a technical firm. And so now they'll have some background information of how the technical field still works.
It's amazing how getting kids access to this before they make that decision of postgraduate. You know, do I want to go into a trade field? Do I want to go to a 4-year college? Do I want to go to a 4-year college and realize that I wasted 4 years and I should have been in a trade school? So those decisions, and West York providing the students an ability to make that determination before they enter into thousands of dollars of debt is huge financially for those students, as well as such a huge educational benefit to the students here. So that's great.
Well, we definitely have to put a shout out to JA for their STEM program. We have all of our 10th graders do that. And so that following year, they have the opportunity to schedule various different classes. Engineering is one of them, the computer programming. So having them see the capabilities in 10th grade is really helpful.
Yeah. Did you try to how far do you integrate STEM within your K through 12 education system? Do you get into elementary schools? When does it really start here at West York?
Yeah, it's really starts elementary school. Being a part of the science curriculum committee, we kind of look at our K to 12 science program.
Yeah.
Obviously, the push nationwide is STEM, and so we're trying to do that down there as well. I know we're working on some makerspace areas where the kids can get in and have tables to make things that they want to make. The middle school, we're definitely doing that. We'd really like to have, obviously, more funding to put teachers in effect to do that. But I know with the teachers, what we've got, that's what we're trying to do, is to get those kids to integrate the science, the math, and the ability to put it all together and make something.
It's amazing. What things do you think the state can do to help West York School District continue to do this wonderful, new, innovative class? Were there hurdles from the state at all, or was I usually say local is better, because you can do things a lot quicker, a lot faster, a lot more effective. But what do you think we could do as a state to help implement some of these changes?
Honestly, the two things I can think of, funding. I mean, obviously money is money, but in order to have STEM education, you need to have the STEM materials. You know, it'd be great for us to have a CNC machine. We have 3D printers, a couple of those are big things. The computer technology, more of the Arduinos. We got a grant from this for First Energy, but there's a 1-year grant. So who knows what this class is going to be able to do next year, depending on what we receive. Probably the second thing is, from my perspective, the fact that there are certain mandatory tests kind of dissuades some kids from the ability to take classes like this because they might have to take biology,
Yeah.
and in order to pass that test. And so that limits them. They might take biology for 3 years, and that kind of limits their ability to take classes like this. I mean, it's still science, but it limits them in their scope.
Gotcha.
So I'd like to see that be changed.
Yeah, there's constant discussion over the amount of over-testing and right-sizing it so it's effective for the students, the teachers, the state, the federal government, and hopefully we can get some of those done so we can make it much better.
Let the teachers teach. That'd be great.
Mr. Wolf, thank you so much for taking time out of your day to give us an insight on the awesome things happening here at West York School District and being a true leader in connecting students with STEM education. So thank you for your time and keep up the great work.
Thank you for coming in and getting our input.
Thanks for watching. I hope you enjoyed this edition of Legislative Report with State Representative Seth Grove. If you have any questions about what you have seen on this show, contact information will follow. Thanks again and tune in next time to Legislative Report.